Section 10.8 is titled Transformer Taps. The power transformers in particular have these things called taps that allow us to sort of dial in the specific voltage that we need. The reason for that, and it gives this example in the textbook, say a distribution transformer had a ratio of 2400 volts on the primary side, and it drops it down to 120 volts. So, that would be something that, like you have coming into your home. That's the voltages that we're actually working off of. So what might actually happen is the transformer itself is designed to this 2400-120 ratio, but the actual transmission line voltage may be never higher than, say, 2000 volts. Well, we know enough about turns ratios and the like to know that, that whatever we put in is going to be determined by the primary to secondary turns ratio. So whatever we put in is going to get this output voltage at a certain level. So, if I put 2000 in for a transformer that was designed at 2400, I'm going to get much less out than 120, which is my desired voltage. So there's a way to do that, and if you end up with a situation like that, incandescent lamps, and he talks about electric stoves, electric motors, all this sort, they're designed to operate at certain levels. And so, it's something that has to be taken care of. And with transformer taps, we're able to do that. So what we're looking at in figure 1013 is a transformer, distribution transformer, and it's got these different taps, from 1 to 2. As we look at this thing, from 1 to 2, that's the design for 2400 volts, right? So that's that. And then from 1 to 3, it's got a different turns ratio, and 1 to 4 is another, and 1 to 5 is another. On the output side, what we've got is always 120 volts out. All right, so the way this thing works is the taps, and the taps are just these really connections to these physical points in the transformer. We're taking less turns when we go from 1 to 3 than we are from 1 to 2. So it changes this, right? It changes that, and that causes the voltage to change. So the taps enable us to change the turns ratio so as to raise the secondary voltage by 4.5, 9, and 13.5%. And you got to say, where does that come from? Well, there's particular reasons why these percentages are calculated the way that they are. So what we can do is we can maintain a satisfactory secondary voltage, even though the primary voltage may be 4.5, 9, or 13.5% below the normal, which we call 2400. So if we're referring to the transformer in figure 1013, and the line voltage was 2076 instead of 2400, what we could do is use terminals 1 and 5, okay? Because if we look at what is that percentage here, if I take 2400 and I multiply that by 0.135, I say get 324 minus 2400, and that gives me 2076 volts, okay? So, I can accommodate these percentage voltage differences across here. So that gives us some options with this. Some transformers are designed to change the taps automatically whenever the secondary voltage is below or above a certain preset level. These are called tap changing transformers, and they help maintain the secondary voltage out here within plus or minus 2%, which is a good thing for all the loads that are connected to that. And quickly here, I got to quit talking so much on these things. I'm sorry, but if you were a captive audience in person, you know, I would have more show and tell for you and all this. But what's really interesting in this world of power now is so many of these traditional devices like transformers, there's so many features being added to them, incorporation of controls and electronics, and monitoring and so forth and so on, and it makes them work so much better. It's an interesting place to play, and I hope that some of you might even find yourself, you know, being as interested in this to get into it. You know, you are living in the city with the largest energy company in the United States, which is Duke Energy. And there's a lot of good opportunities out there for you to follow up on. All right, I'm out of here. I will stop now.